Hello everyone. The first thing, if you are using a GPU for the first time, please verify your Kaggle account with your phone number. After verifying your Kaggle account, only Kaggle allows using a GPU. That will be the first requirement if you are a first time Kaggler. So next, I will show you how to copy and edit a Kaggle public notebook. Here I will open someone else's notebook. Under code section, there are many public notebooks available. So this is the original notebook. We can't make any edits or run this notebook. If you want to experiment it, you will have to copy and edit. Now this copied notebook is in our Kaggle account folder. So we are able to run this code and make necessary modifications if you want to. Also you will see that the linked datasets in the original notebook are also linked to this copied notebook. Also, if you have verified your Kaggle account with the phone number, you will see that when you copy my Kaggle demo DeepSeek math demo notebook, that I have set the accelerator to GPU T42 in the public notebook. When you copy my notebook, it should be set to GPU T42 by default. Also, if you haven't verified so far, you can check from here. If you try to verify this, the Kaggle will say that you need to verify the account with the phone number, and there will be a link to do so. So now I can assume that you have the copied version of my demo notebook. So let's go to the notebook from here. This is my profile, and under code DeepSeek math demo, that I'm going to walk through this code. First, let's import the necessary packages like Hugging Face Transformers, Auto Tokenizer, Auto Model for Casual LM, and Generation Config, and the datasets. At the first time, it will take a very long time to start this notebook because it's been attached to very large DeepSeek math models, which are like 10 gigabytes. Actual notebook starts from here. Our focus is to compare the DeepSeek math models. So first we load the dataset. Here we are going to load this GSM 8K dataset, which consists of 8,500 grade school math word problems. Each problem is like a story with numbers. The model needs to figure out what maths to do, and we expect that the model will answer the problem with step-by-step reasoning. So these are 10 questions out of that larger dataset. With these 10 questions, we are going to prompt the DeepSeek math model. For that, first we have to load this DeepSeek math base model. What is DeepSeek math base model? It is It has finished loading. So we can start DeepSeek base model evaluation. When you are running the code for the first time, it will take a longer time. Because right now the system already had the checkpoints in the system that it didn't take much time turnaround time to load the models. So now we are trying to evaluate model responses against our sample 10 maths problems. This DeepSeek math based model is a post-trained model which was trained based on the foundations from DeepSeek coder model. When pre-training this DeepSeek math model, the DeepSeek research frontier lab has used a larger mathematical corpus. On the top you can see the system performance. There are 2 GPUs. Now we can see out of 10 questions, 5 questions are answered by the LLM. For evaluation, we are using this evaluate model correctness helper function that we instantiated in top of the notebook. Also, if you want to read more about this GSM8K dataset, you can access the dataset page from this link. Open in new tab. Now the evaluation is almost complete. The model is responding for the last question. The problem is about some airport. Now we can see the evaluation results. Out of 10 questions, we can see lots of incorrect answers. So the base model accuracy is only 30%, that it has only answered 3 problems correctly. Now let's see to load the instruction tuned model. So this instruction tuned model is a fine-tuned model based on the base model. On the foundations of the DeepSeek math base model, the research lab has fine-tuned the instruction tuned model, that it has instructed the model to follow more mathematical related instructions. If you are interested to check out the DeepSeek math model page, you will find a paper link to the DeepSeek original paper from here. Still the instruction tuned model is loading. The loading is complete. Now we can start evaluating the fine-tuned model. If we look at the responses from the base model, you can see that inside the response text there is a lot of unnecessary characters, repeating characters. That the mathematical solution the model has provided is not structured. With the instruction tuned model, we can expect that the generated responses would be more structured, as the instruction tuned model is specifically tuned in a way to follow the instructions. You will see a good difference between the responses, that the generated responses are in a better structure, and the model accuracy is 70%, that it has answered 7 questions more accurately. Next, we can try to load the reinforcement learning model. As these models are too large, sometimes the system cannot load the model parameters into the GPU because it has already two large models in the system. So it gives a warning that the big modeling parameters are on the meta device because they were offloaded to the CPU. Without running the code with this warning, I suggest you to stop the session. so we can't load all the three models into the system. After instantiating the helper functions and package import, I will again try to load this reinforcement learning model. This DeepSeek math reinforcement learning model is trained on the foundation of DeepSeek math fine-tuned instruction fine-tuned model. It utilizes the group relative policy optimization algorithm, which was proposed by DeepSeek Frontier Research Lab initially. So the challenge was that we have only T GPUs available to run this notebook on the Kaggle. Because of that, we were not able to load all the trained models into one notebook at the same session. So I first loaded the base model and the instruction tune model and ran the evaluations for those two models. And next we stopped the notebook session and restarted the session, imported the packages, instantiated the helper functions. Now we are trying to load the reinforcement learning model. If everything goes right, we can next evaluate the reinforcement learning model against our 10 sample questions. So the base model accuracy was only 30%. Instruction tuned model accuracy was 70%. And let's see the accuracy for the reinforcement learning model. For the reinforcement learning model, the overall accuracy for the sample questions was 80%. So here we can conclude our demo notebook, and I suggest you play more with the notebook and be more creative. And also we can save this notebook from here. That's all. Thank you.